Hi, welcome to this course on TensorFlow. TensorFlow is a program that helps engineers build and train machine learning models. In this course, you will learn about tensors and how to work with tensors using TensorFlow. We will start by looking at what tensors are. We will then learn how to build tensors using data. We will then see how to perform basic and intermediate math operations using TensorFlow. TensorFlow can also work with GPUs and TPUs, which are types of computer chips built to extend TensorFlow's capacities. These chips make TensorFlow run faster, which is helpful when you have a lot of data to work with. At the end of the course, you will have a good understanding of what TensorFlow is and how to use it to build deep learning models. We will also be building a computer vision project where we will create a simple TensorFlow model to recognize handwritten images. This is a beginner level course, but I'm assuming some basic knowledge of Python and machine learning. You don't have to be an expert in machine learning, but if you understand how data is used to train models for prediction, you'll be able to understand this course. If not, please find links to a couple of intro videos in the course description. If you're stuck at any point of the course, send me an email at help@manishamshiva.com and I'll get back to you as soon as I can. So let's get started. In this lesson, we will look at what a tensor is, followed by the popular deep learning library TensorFlow. Let's first look at what a tensor is. A simple explanation would be that a tensor is a multidimensional array. For example, we have scalars, which is just a single number. Then we have a vector, also called as an array. Then we have a matrix, which will be a two-dimensional array. Finally, we have a tensor, which is an n-dimensional array, which means it can have any number of dimensions. In TensorFlow, everything can be considered a tensor, including a scalar. A scalar would be a tensor of dimension 0, a vector of dimension 1, and a matrix of dimension 2. Now, this is useful because we are not limited to working with complex data sets in TensorFlow. TensorFlow can handle any type of data and feed it to machine learning models. TensorFlow is an open source software library for building deep neural networks. Google Brain Team was the one who built it, and it is now the most popular deep learning library in the market today. You can use TensorFlow to build AI models including image and speech recognition, natural language processing, and predictive modeling. TensorFlow uses a data flow graph to represent computations. To put it simply, TensorFlow has made it easy to build complex machine learning models. TensorFlow takes care of a lot of work behind the scenes, which makes it useful while building and training any type of a deep learning model. TensorFlow also manages the computation, including parallelization and optimization on the user's behalf. TensorFlow has a high-level API called Keras. Keras was initially a standalone project, which is now available within the TensorFlow library. Keras makes it easy to define and train models, while TensorFlow provides more control over the computation. TensorFlow supports a wide range of hardware, including CPUs, GPUs, and TPUs. TPUs are tensor processing units, built specifically to work with tensors and TensorFlow. You can also run TensorFlow on mobile devices and IoT devices using TensorFlow Lite. TensorFlow also has a large community of developers, and it is updated with new features and capabilities almost on a monthly basis. Hope this video helped you to understand tensors and TensorFlow in detail. Next, we will start working with TensorFlow on a Google Colab notebook. Let's start writing some code. I'll be using a Google Colab notebook, and you can find the link for the completed notebook in the course description. I'll first connect this notebook to a CPU. Let's wait for a minute. Now it's initializing. And great, it is connected. If you don't know, Google Colab notebooks help us to run Python and TensorFlow code on the web. It's much easier to work with rather than setting up a local development environment. Now let's start by importing TensorFlow and printing out the version. You can press Command Enter or Control Enter to run the code block. Great, we are using version 2.9.2. If you have a different version, don't worry about it, there won't be much difference. Let's start by creating a scalar using tf.constant. tf.constant is a function that we will be using throughout the course, but in real world scenarios, you won't be using it that much because TensorFlow will handle a lot of tensor creation for you. But for now, let's create a scalar. I'll give the input as 7 and let's print it. You can see that we have created a scalar with the value 7. It doesn't have a shape because it's just a single value, and the data type is integer 32. Now let's create a vector. The input will be an array with 2 values, and now let's print it. Great, we can see that we have created a vector of shape 2 and data type was integer 32. Now let's try creating a matrix. The input will be a 2-dimensional array, 10, 11, and 12, 30. Let's print it. We have created the matrix which has shape 2, 2. It's a 2-dimensional array and the data type is integer 32. Now let's create a tensor. I will call it tensor tf.constant. If we copy paste some values and let's print it. Great, you can see that we have created an actual tensor which is also a 3-dimensional array, and it has a shape of 3 by 1 by 3. So this is how we create an actual tensor using tf.constant. We can see that the data type is integer 32. What if we want to use a different data type, let's say float 32? We can use this d type as an argument and pass it when creating a tensor. I'll just copy the same tensor and I'll call it tensor1, same values, but I'll specify the data type is float 32 and I'll print it. Yeah, you can see that now the data type is float 32. This is how you can change the data type when working with TensorFlow. In case you run into issues when you're working with large models and TensorFlow size, it can't handle it, try changing the data type. In real-world scenarios, you'll be dealing with tensors of higher dimensions and even bigger shapes. In the following lessons, I'll also show you how to convert a real-world data set, like a group of images, into a tensor. We have seen tf.constant, which is used to create constant tensors. This is what you'll be using throughout the course. But if you want to create a variable tensor, you can use tf.variable. The difference between constant and variable is that you can change the values in a variable tensor, but in a constant tensor, you can't change the values. Let's create a variable tensor. I'll use the same tensor and call it var tensor, then use tf.variable. And now I'll print it. You can see that we have created a variable tensor with the same shape and a data type of integer 32. One of the most important attributes of a tensor is its dimension. So let's look at what the dimension of each of these values are. We'll start with the vector. Let's print the dimension using the ndim property, vector.ndim. So you rerun it. We can see that its dimension is 1, which is expected. And if you look at the scalar, its dimension will be 0 because it's just a single value. Yeah. And for matrix, there will be dimension 2. There we go. And for a tensor, the dimension will be 3. Think of dimensions as the number of columns. For example, if you're using a data set to calculate housing prices, you'll be inputting the square feet, the location, and maybe a few other inputs. Each of these inputs will be called as dimensions. They can also be called as features. So I hope this lesson helped you to understand how to create tensors and find basic attributes like shapes and dimensions. In the next lesson, we'll see how to generate tensors, and also we'll see how to load tensors from NumPy arrays. Now let's look at how to generate tensors. In most cases, you won't be creating tensors from scratch. You will either load a dataset, convert other datasets like NumPy arrays to tensors, or generate tensors. Let's see how we can generate some tensors. We will first create a tensor with random values. There are two common ways you can do this. You can generate a normal distribution, or you can generate a uniform distribution of data. The normal distribution is a bell-shaped curve. So this represents the distribution of data. This means that most of the data will be close to the average and fewer data is away from the average. It basically means that the probability of getting a value near the average is higher. The uniform distribution, however, is a straight line that represents the distribution of data. So all the values in a uniform distribution will have an equal probability of occurring within the given range. There is one more thing you need to know before we start generating random values. There is a concept called seed. A seed is just a value, and if we use a seed value, we can regenerate the same set of data multiple times. So you know that we are going to generate random values, right? So if we use a seed, that same random values will be generated again and again. This is really useful when you're working with a machine learning model and you want to test that model against the same set of data. So let me create a seed. I'll call it seed tf.random.generator from seed. I'll set a value, let's say 42. Now I'm going to create a set of random values based on the normal distribution. Normal tensor is seed.normal, and I'll input a shape. Let's say 3 by 2. It has been created. Let's print it. Great. We have a tensor with the shape of 3 by 2. And if you plot all these values, you can see that it will form a bell curve. So all these belong to the normal distribution. Now let's create another random tensor with the uniform distribution. Call it uniform tensor. C.uniform. I'll give it the same shape. 3 by 2. And let me print it. I'll come in the shop for now. Now this is a uniform tensor with a shape of 3 by 2. So this is how we can generate a set of random tensors using normal and uniform distributions. Now let's see how to create tensors with zeros and ones. You might be wondering why we need this. In TensorFlow, tensors filled with zeros and ones are often used as a starting point for creating other tensors. For example, they can also be used as placeholders for inputs in a computational graph. So let's first create a tensor with zeros. For that, we'll be using the tf.zeros function. Let's call it zeros. And we'll give it a shape. You can see that we have created a 3 by 2 tensor filled with 0 values. Now let's create the same tensor with ones. tf.ones shape equal to 3 divided 2. Let's print it. Here we go. We have a tensor with shape 3 by 2 filled with ones. There are more different types of random tensors that you can create using TensorFlow, but these are the common ones that you will be using. Now let's look at how to convert a NumPy array into a tensor. If you don't know what NumPy is, it is a Python library for numerical computing. It helps us handle large datasets and perform a variety of computations on them. And before we had TensorFlow, NumPy was all we had when we were working with machine learning models. So let's first import NumPy and create a NumPy array. I'll create a NumPy array called NumPy_arr, and I'll be using the aRange function, which tells NumPy to generate a list of values, let's say from 1 to 25, and the data type will be NumPy.int 32. Let's print it. There we go. We have an array with 24 values ranging from 1 to 25. Now we are going to convert this into a tensor. TensorFlow has native support for NumPy, so you can easily convert your NumPy arrays into a tensor object. Let's call NumPy tensor. It is tf.tensor constant, and my input will be the numpy array I just created. And the shape will be, I can set a custom shape. So I will say 2 by 3, 4 by 3. And let's print it. There we go. We have converted a one-dimensional numpy array into a 2 by 4 by 3 tensor. You'll be doing this often when you're working with real-world machine learning problems, because oftentimes there'll be other machine learning algorithms or other frameworks which people will use, and you'll get the final data set in a numpy array. So it's very important to understand how to convert numpy arrays into TensorFlow objects. I hope this lesson helped you to understand how to generate tensors and how to convert numpy arrays into tensors. So in the next lesson, we'll see how to perform some basic calculations, aggregations, and matrix multiplication using TensorFlow. Let's look at some basic operations using tensors. We will start by looking at how to get some information from our existing tensors. Let me create a new 4D tensor. I'll use the tf.zeros function to generate a 4D tensor. Let's call it rank 4 tensor. And the shape will be 2, 3, 4, 5. Let's print it. So we have created a 4D tensor with a shape of 2, 3, 4, 5. Now let's get some information about this tensor. I'll first print the size of the tensor. So for that, we use tf.size. Yeah, let me also print out the shape. For that, I'll call the tensor.shape. Then let's print the dimension. We already seen this. And for tensor.endem. Great. Let's see what comes up. There we go. The size of our tensor is 120 because there are 120 values. We have the shape and we have the dimension. This will be useful when you're working with complicated tensors and if you want to quickly get some information about the shape and the size and dimensions. Now let's perform some basic operations on tensors. So let me define a simple tensor. If we call it basic tensor, tf constant, and create a 2D tensor. Let's say 10, 11, and 12, 13. Great. Let's try addition. I just want to add a number to each value in the tensor. So you can simply say basic tensor plus 10. This will add 10 to all the numbers in the tensor and we print out the result. Let's try subtraction. Let me also include multiplication and division. Multiplied by 10, clearing it, divided by 10. Let's print out everything. There we go. The first is the addition, second is subtraction, third is all the values multiplied by 10, and the fourth is all the values divided by 10. This division is a bit important because we'll be using it in our project. So there is a concept called normalization where we try and convert a set of values into 0 to 1. I'll explain that in detail when we come to that lesson, but please keep this in mind. Now let's look at matrix multiplication. This is also something that we'll be doing often when we are working on real-world machine learning projects. Let me quickly create two tensors. We'll call it tensor 011, 0 tf constant, 2, 2, and 4, 4. And I'll create a new tensor called 012, and I'll say 2, 3, 4, and 5. Before we go into matrix multiplication, please keep in mind that the inner dimensions of the tensor that you are trying to multiply should match. For example, let's assume you have two tensors, both of shape 3 by 5. This multiplication won't work. But if you have two tensors with shape 3 by 5 and 5 by 3, that will work because the inner dimensions match. The final result of the multiplication will be of the shape of the outer dimensions. So if you have two tensors, each with 5 by 3 and 3 by 5 as their shapes, the final result will be 5 by 5. So let's try multiplying these two tensors. We'll be using the tf.mathmul function. We print it tf.mathmul, tensor 011 and tensor 022, 012. There we go. We have the product of these two matrices. Let's look at two more matrix operations, reshape and transpose. We will often use reshape to change our matrix structure when training neural networks. For example, an image pixel of matrix 28 by 28 will be converted into a one-dimensional array of 784 values. You will see this in our upcoming project and I'll explain this in detail. But for now, understand that reshaping is a very important concept in TensorFlow. I'll use the same tensor that we created in the previous code block, tensor 011. Let me reshape it into 4 by 1. For that, I'll be using df.reshape, and my first argument will be the actual tensor, which is tensor 011, and the second argument will be the shape. Let me say 4 by 1. So if you see this, I'm trying to convert a 2 by 2 tensor into a 4 by 1 tensor. There we go. So the values 2, 2 and 4, 4 are converted into a 4 by 1 tensor. This is how we reshape a tensor. Now let's see how to transpose a tensor. We'll be using the df.transpose function, and we're going to give it the same tensor 011. Let's try it. There we go. You can see that the values have been transposed. For example, the values 2 by 2 and 4 by 4 are now 2, 4 and 2, 4. If you don't know what transposing a matrix is, it is just converting rows into columns and columns into rows. Now let's look at performing some aggregations using tensors. In often cases, you will want to find the sum, mean, median, or even standard deviation of a tensor. Let me create a simple tensor. df.constant. I'll just do a simple array from 1 to 9. 2, 3 and 4, 5, 6. 7, 8, 1. I'll set the data type as float 32. Now let me print out some values. First, I want to find the minimum value within this tensor. For that, I'll be using the reduce min function, df.reduce min, and I'll give the tensor value as input, 0, 1, 3. Let's print it. You can see that the minimum value is 1. Now let's do a few more aggregations like this. I'll reduce lats, copy this, then I'll find the sum, let's try printing these. So the minimum value is 1, the maximum value is 9, and the sum is 45. Great. Now let's open a new code block and try some more aggregations. I want to print the standard deviation of this tensor. For that, I'll be using df.math.reduce std and the tensor as the input. And I want to print the variance, which is also in df.math. Let's try these. There we go. We have the standard deviation and the variance. Now let's try a few more simple aggregations. We'll try and find the square root, and the log of all the values of the tensor. First is square root, which is df.sqrt tensor. Then the square, which is df.square tensor. And I want to print the log, which is in math. So df.math.log of the tensor. Let's print it. You can see that df.square root has found the square root for each value of the tensor, and df.square squares all the numbers in the tensor, and finally math.log finds the log value of all the values of the tensor. These are the basic operations that you need to know for now. In the next video, we will look at an important concept called one-hot encoding.